Question number 27. The following procedure was carried out at 298 Kelvin to determine the distribution coefficient Kd of a monobasic organic acid between dichloromethane and water. 50 centimeter cube of a 0.2 m aqueous solution of acid were mixed vigorously with 10 centimeter cube of dichloromethane, and the two layers were allowed to separate. Thereafter, the dichloromethane layer in the bottom of the flask was drained out. 10 centimeter cube of 0.02 m NaOH solution were required to neutralize the acid remaining in the aqueous layer. Assume that the acid does not dimerize in the organic phase. Kd of the acid between dichloromethane and water at 298 Kelvin is. Let's draw a simple diagram for this. They say the dichloromethane layer is here at the bottom. So this will be our aqueous layer, DCM, and its volume is 10 centimeter cube. Aqueous layer is 50 centimeter cube. Now they have used 0.2 m 50. So this will be the amount of HA in the aqueous solution. That will be 0.01. So here we have 0.01 moles. Let's assume that X amount will be distributed to the organic layer. So X amount will remain in here. And they say 10 centimeter cube of 0.02 NaOH required to neutralize the acid in the aqueous layer. So we can calculate this value here. So the reaction will be NaOH reacts with the organic acid. They say it's a monoacidic organic acid, and you will get NaA and water. The stoichiometry is 1:1. Therefore, the amount of NaOH will be equal to amount of HA. The amount of NaOH will be 0.02 divided by 1000 into 10. So this will be equal to the amount of HA, which will be equal to 2 into 10 to the power minus 4 moles. This is the number of moles of HA in the aqueous phase. So this is the total HA that we took, this value. Can be written as the total amount of HA we used will be, we can write it as 100 into 10 to the power minus 4 moles. Now we took this amount of HA into the aqueous layer. When we shake it with 10 centimeter cube of dichloromethane, the remaining amount was this one. Therefore, extracted amount, that means amount of HA in the DCM layer. HA in the DCM layer will be 100 into 10 to the power minus 4. It's the total amount minus the remaining amount. So the dichloromethane layer will have 98 into 10 to the power minus 4 moles of HA. Now we have the two values. This is 2 into 10 to the power minus 4. This is 98 into 10 to the power minus 4. So we have the equilibrium values of HA moles in the two phases. Now let's substitute it for the Kd expression. Now when we are writing the Kd expression, they have said specifically Kd of the acid between dichloromethane and water. So you have to put the concentration in the dichloromethane layer to the numerator. So the Kd expression will be like this. HA concentration in DCM, dichloromethane, divided by HA concentration in aqueous layer. Right. The DCM layer concentration will be, the amount is 98 into 10 to the power minus 4. 98 into 10 to the power minus 4. It was in 10 volume here, 10 centimeter cube of volume here. So it's divided by 10 and multiplied by 1000 to calculate the concentration, and divided by the HA concentration in the aqueous layer. Aqueous layer number of moles is 2 into 10 to the power minus 4. So it will be 2 into 10 to the power minus 4 divided by the volume is 50 volume. So it's divided by 50 into 1000. Now when we simplify this, you will get this cancelled off, this 10 to the power minus 3 cancels off, this one gets cancelled off, and this will give 49. So what we have to do here is 49. Now this 5 goes up here, 49 into 5. This can be written as 5 into 50 minus 1. So this is 250, this is 5, 250 minus 5 is 245. So the KD value will be 245, and it doesn't have units because the 2 units are cancelled off. Okay, the answer for the 27th question is the 5th one. Okay, let's move on to the next question.